Hello and welcome. So today, as usual, we'll try to solve some coding problem under 40 minutes. Let me quickly check that everything is up and running. Okay, looks good. This stream is for entertainment purposes, and let's see what's the problem we've got today. In past several times, it was just an easy one. It will be an easy problem today too. Easy problem. There we go. All right. Chess, interesting. On an 8 by 8 chessboard, there is exactly one white rock. Alright, so it can go on the straight lines, right? And some number of bishops. Alright, B. Number of white bishops. Black pawns and empty squares. So interesting. When the rock moves, it chooses one of four cardinal directions: north, east, south, or west. Then moves in that direction until it chooses to stop, reaches the edge of the board, captures a black pawn, or is blocked by a white bishop. A rock is considered attacking a pawn if the rock can capture the pawn on the rock's turn. Alright, the number of available captures for the white rock is the number of pawns that the rock is attacking. I see, like in example 1. Here is the board. There is no white bishops, blah blah blah. And then we see that it attacks 3. In this example, it attacks 0. Yeah, I already know, it's a very simple problem. Super simple problem. Yeah, so what can I say? First, we need the location of the rock, right? And once we have the location of the rock, we know that we can move up. So we already know so that at maximum it can attack 4, right? So we just check in each direction of the rock if there are any pawn, right? And that's it. All right. I wish they just gave you these initial coordinates of the rock. All right, so let's see. Int So we have these two. We can say I0 and 2. By default, there's 0 anyway, so that's the point. So we say while I less than board. We know that it's always 8 by 8, right? It's exactly 8, so we can just use 8. Actually, we can use a little bit less memory to track this. And also use boolean found by default false. So we do the same for j, right? Then we say board j board ij equals the rock found true. Or actually we can do this, right? It found we break we break. Otherwise we do j++ here, right? And I++ here. So the idea is we're just searching, which is at most 64 steps until we find the rock. Once we found ij, now it's easy, right? Now all we say is while let's say for unsigned integer, right, of 8 and t, you can call it I, that is equal to I minus 1, right? So 1 to the, so I is what, vertical, so 1 to the let's say up, right? I greater or equal than 0, and we say I minus minus. So now we have int cint equal 0 by default. So we say if we can make it actually const because we don't care. If board ij equals b, we basically break I, right? So we fix j, we go I to the up, then to the down, right? else if board ij equals to p and we say int plus plus and then also break. Now we repeat this 4 times. So then we might consider to do some refactoring here, although it might is not necessary maybe for easy problem. Less than 8, I plus plus, same thing, right? You can say this is search north, search south, then you can get it 4 more searches in the same fashion. As you can see, the structure inside is exactly the same. So this thing inside can be put into the different, into some helper function. So we can say namespace, right? So let's say it's the void function. Oh, let's say it's a Boolean function, right? So Boolean function, and in the, let's say, check cell, we have this board, obviously, then int I, int j. So what do we do here? And we also need int int, right? All we do here is do the check. Obviously we don't break or anything. Interesting. This. All right, you don't need to if board ij equals to what dot, right? Return false, so we don't need to break. Else if so basically then we don't care about B case because we will break anyway. So all we need to say is just else. All right, we already know that we need to break, so we will return this after all anyway. So all we say here is this, that we increment our counter and we return true. All right, that's it. So very trivial function. So what we do here is we just do if check cell that we say what board II J and CNT, we break, right? And that's it. So yeah, much better. So we do the same thing here, same thing here with respect that now it's JJ, right? That is equal J minus 1 and JJ greater 0, JJ minus 1, so it's JJ. Same thing here, JJ, J plus 1, JJ less than A, JJ plus plus, so it's I, JJ, sorry, this one, right? So this is what? This is west, this is east, right? That's it. Another cool function could be just void, right? Find rock, and it is basically just this thing. Int I, int j, right? Doesn't return anything. So what we do here is say, okay, if I and j less than 8, all right, do we need to pointer to pointer? Actually, maybe we don't need to do this. Yeah, if I remember correctly, it will access the memory there. But for this thing, we need to, if we want to change it. Alright, and then we say find rock. So we obviously know that is there, so we just say it's board, and then I, and then J, right? It's actually you int here, and actually count also you can be your integer of 8, because we know that yeah, I think that's it. Let's see if it runs. Obviously not. Correct. All right. Interesting. So where it is, something violates the region. Hydrate sanitizer. Yeah, I think it breaks of finding the rock. Rock at IJ, and it's nothing. Interesting. Or maybe it's nothing because it's unsigned integer, so it has no idea how to convert it. Alright, let's for now quickly switch to integers. So to save some sophisticated debugging information, we need to just to make sure that we are on the same page is what we're doing in the code. Right. Nice. So let's see, run the code. Because we need integer. Sure. Alright, so let's see. What was the issue? Rocket 8 and 8? Seriously? So once we found this equal R, let's say it's false, so we never enter, okay, we found it, it's true. So it's like, okay, true, break, true, break, and that's it. So this is fun. And they cannot be equal to 8, by the way. This should be less than 8. Is it because of this? No, it should be this one, but I wonder. It's like super simple, but it doesn't work. Oops. Cell at IJ. IJ has. Let's just check what we have here. All right. But why I is 8? Oh, because it just keeps incrementing. Oh, now I see it. Now I see it. Then we should say dot j equals 0, right? That's what we've missed. We need to reset this thing. Alright, now it works. So cell at blah 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 PR. Okay, we found it at 2 and 3. Maybe, I don't know. So we don't need this, and we don't need this. Now, because we know what the issue is, what was the issue, right? Let's switch to your integer. Everywhere, right? Why not? 2, 3, 4, 5, and 6. And then we say this, and this, and run the code, and it works, right? Still should work. No, it doesn't. Now we have this overflow stuff, body address. Alright, too much too. What if it's just because of this thing? Because we need to return integer. Alright, so let's keep uint, integer. Alright, so same thing, but int is an integer. Alright, so maybe this one should work. No. Whatever. Never mind. It's very fast. It's cool. Memory sucks. It's not cool. But technically all we track is just 2 integers, 3 integers, right? So it's good. 12 bytes of data. And maybe some internal integers that we create here within the cycles. Not a big deal. Alright, let's submit a few more times to see what's the best score we can get. Should we stop here? Yeah, I think we can. It's okay. So let's switch to the whiteboard. And so again we hit 100% for our time complexity, and for space complexity we've got 71. So in total 171. Nope. 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 Why it's so complicated? Alright. I think something similar already was there. So that's it for today. Thank you and see you